Servos are the base of almost all hobby robotics. But the new Raspberry Pi Pico here doesn't come with a nice to use library to control servos like an Arduino does, so I went about making my own. So what's actually inside a servo? Well, there's a control board and a potentiometer, a DC motor, and a gearbox. What happens is power and the signal from the microcontroller comes in on these three wires. The control board reads the potentiometer and the signal coming from the microcontroller and decides which direction it needs to turn the motor to achieve the desired rotation given by the microcontroller over the orange wire. But what does the signal coming from the microcontroller actually look like? Well, it's a PWM signal, if you'd believe it. PWM you might recognize as the way you dim an LED with an Arduino. But it's the exact same kind of system that you use to control the position of a servo. What you have are these cycles, and these cycles are 20 milliseconds long. The way you set the position of the servo is how long you have the orange wire of the servo tied to high during those 20 milliseconds. If you want it at 0 degrees, you want to have the signal set to high for 400 microseconds of those 20 milliseconds. In the same idea, if you want to set it to 180 degrees, you need to have it set to high for 2,400 microseconds of the 20 milliseconds. So now that we know what the code has to do, let's look at how it does it and then how we use that code in our other projects. So in this script, there are two functions: set servo, so that's like setting it up, and then set mils, that's how you set the position once you have it set up. So in set servo, right here it just sets the GPIO pin, and then here it sets the timer up correctly so that it runs at the 50 hertz or 20 milliseconds that the servo requires. This line starts it, and this line just makes sure that it's set to a value that the servo can handle. And then set mils is really simple. It just sets how long it is on per cycle on that GPIO pin based on the mils you input here. So let's look at a single servo sweep example. Now this is going to vary from what you have to do in Arduino, or what you might be used to in Arduino, because in Arduino what you do is you declare a servo object, then whenever you want to change the location of that servo, you modify that servo object. That's not possible in C, because C is inherently not object-oriented and doesn't have objects at all. So what you have to do is you take your servo pin, and then whenever you want to modify that servo location, you just reference that servo pin. So if we look in the main function here, we take our servo pin, and we use the set servo function to make that pin act as a servo. And then forever, in this while true loop, we set the current mils to move in whatever direction we're going. If it's too far in either direction, we change what direction we're going. And then we just set that servo position by referencing the servo pin to whatever location we're currently at, and then we sleep 10 microseconds. And that just pauses it. Loaded the single servo sweep code onto the Raspberry Pi Pico here. These two wires are just 5 volts coming from my power supply. And you can see the servo behaves exactly like what we would expect from a servo sweep example. We've seen the single servo sweep example running, so now let's look at a 2 servo sweep. And I included this just to show you that it can run up to 16 servos, because that's how many hardware PWM ports the Raspberry Pico has. So in this script, it's basically exactly the same, except we're running 2 servos, one on pin 0 and one on pin 1. So it sets both servos here, and then in the true loop, in the while true loop, we have basically the exact same code copy and pasted twice. So both servos move at different speeds, as you can see I've defined here, and they start in different locations and in different directions. So let's look at what that looks like on the Pico. Here is the 2 servo sweep example running on the Raspberry Pi Pico there. Still the same 5 volts coming from my power supply. And you can see that the 2 servos are operating independently of each other.
And that little stutter there, when this servo reaches the ends, as you can see right about there, that's probably just because I'm going slightly outside of the range of that it's expecting in microseconds. So it's getting to the end, and then we're going even lower, even higher than what it expects, and it just kind of waits as far as it can go.
All the code shown in this video is available on GitHub. The link is in the description. If you have any questions, leave a comment. I'll be sure to answer any questions down there. And if nothing else, make sure to subscribe. I have some really cool stuff coming up with more Pico tutorials, then a really cool robot build involving the Pico. And leave a like. See you next time.